Hi viewers, welcome back to my channel. So now I am going to explain one more experiment in electrical machines lab, especially AC machines lab. Okay, so that is, let us go for power factor improvement of induction motor. So we know that if I take a voltage and current here, this is the angle phi. This phi angle is nothing but power factor angle. So this is for inductive loads. This is for inductive loads. Now when I want to improve this power factor, that means when I want to decrease this power factor angle, I need to add a capacitive load where it draws capacitive current. That means it provides leading kVAR. Leading kVAR. So with inductive load, if I add a capacitive load, then I am going to get the resultant current as shown here. That means this will be the resultant current. That means what? Phi angle is decrease, which implies power factor is increase. This concept is now used for this power factor control of induction, single phase induction motor. So we have a single phase induction motor as shown here, and we have a capacitive load or capacitor bank, which we are going to connect it across the inductor load, and these are the connections. So first I will explain the diagram here. This is the input, single phase supply, single phase AC supply, nothing but 230 volts 50 hertz supply, 230 volts 50 hertz supply. For this, so this is nothing but what? Induction motor, where we have induction motor rotor as this one, and M1 M2 is nothing but the main winding, S1 S2 nothing but the starting winding. M1 M2 is running winding, or some people will also call it as main winding. Okay, this is the wattmeter, this is wattmeter, and this is an ammeter, voltmeter, and this is capacitor bank. This capacitor bank is to be connected across the induction motor. So where that capacitor bank is nothing but this one, and this is the induction motor. If we see here, M1 M2 is the main winding. The same if you see here, where you can see W1 W2 is nothing but the main winding, and this C1 C2 is nothing but the running capacitor. S1 S2 is nothing but the starting winding, or else we can also call it as auxiliary winding. So you can see here. Now this is another capacitor, and we have two types of capacitors here. One is for starting purpose, the other one for running purpose. So now you see here, this is the input supply, this is a fuse, and this is phase and neutral, single phase supply, 220 volts or 230 volts 50 hertz supply. And here, if you want, you can also take an auto transformer input, auto transformer here, or else without auto transformer also we can directly give the supply to the induction motor. Now, so I have taken an auto transformer here, where I have connected input to the auto transformer, input terminals if we observe auto transformer, and output of these auto transformers are connected to one to the voltmeter common, the other one to M. If you observe, this is output of auto transformer, it is connected to common of voltmeter, the other one is connected to M terminal. M and MC both are short circuited, because in this wattmeter it's a what I can say, ML is the current coil, CV is the potential coil. So MC should be short circuited, hence it is short circuited here. Now from L it should be connected to ammeter common. So the L terminal, if you see here, this is the L terminal, it is connected to the common terminal of ammeter. Common terminal of ammeter. Ammeter other end is to be connected to M1 S1. So you see here, ammeter other end, it is connected to M1, nothing but WR1, clear, and the other one WR2 should be connected to S2 and then negative. If you see here, it is connected to M2. This is M2. So the other end of this M2, if you observe here, we are going to have M1 and M2 here. Okay. So the other end is connected 1 to M2 and the other one M1. So M1. This capacitor bank is the terminals here. These are the terminals. Capacitor bank terminals M1 and M2. From the capacitor bank, they are connected to again parallel to this. So that is why M1 is connected to WR1, that is running winding, and M2 is connected to the other end of the running winding. Same way, from that M2, this should be connected to negative. So it is connected to negative here. Voltmeter other end is also connected to negative, and wattmeter 300 volts. If we observe here, this wattmeter V is also connected to negative. And there is one more terminal which is connected to negative, that is S2 winding. If you observe S2, it is connected to negative. If you observe here, this is the S2. This is S2. S1 is connected to switch capacitor. S1 is connected to, this is the switch capacitor. Capacitor other end is connected to capacitor, other end is connected to, if you observe here, this WR1 other winding is connected to capacitor S1, there is CS2, and the other end of this capacitor is connected to S2, and S1 of this is to be connected to the main winding M1. So no need of taking SPST switch here. So we are closing it because the machine is to be operated under no load condition. So this is how the connections for the single phase induction motor, especially for the power factor improvement. Once the connections are given, then we will go for starting the machine. So we are connecting it. We have given 230 volts with your supply, and then 230 volts is applied here. 230 volts, and we are going to get the no load current as 6 amperes. And if you observe, the power factor meter is showing 25. Right, the capacitor bank is this one. So we didn't turn on the capacitor bank across the motor terminals. So this is initially the capacitor load or capacitor bank is initially at its initial position, that means 0 position. Now if we observe, when we add capacitor load here, since the capacitor doesn't take real power, there is no question of real power consumption here, so that can be observed even here. So now the main switch is turned on here. Then now I am just adding 8 microfarad as capacitor. If you observe, if you add one capacitor bank, you observe 5.5 is the current that is taken by the induction motor, single phase induction. And if you observe, the voltage reading, power factor meter reading is not changed. This shows that if we add a capacitive load, real power is not at all changing. Real power remains same because we are adding only the capacitive load. So that reading is to be included there.